We're now going to talk about half-life of radioactive decay. I'm sure this is a term that you've heard before. Perhaps you know how to identify it, perhaps you don't. It's definitely something that you've probably seen in math, though we may be approaching it quantitatively slightly different here. If you approach it the same way that you approached it in, I don't remember if it's Algebra 2 or Math Analysis, that will be fine too. So half-life is defined as the amount of time it takes for 1/2 of a substance to decay. If I were to look at a graph of the amount I have, and the amount can be measured in a variety of units, over the course of time, we would find that as it decays, the amount cuts in half. And then, let's say it cut in half after 1 hour. After another hour, it would cut in half again. After another hour, it would cut in half again, and cut in half again. So you'll see that we have an exponential decay. Mathematically, does it ever reach 0? Maybe, maybe not. What we have whenever we have atoms together is we have a probability that one will decay or not. At some point, let's say we have a bajillion atoms, and then we're down to 2. And then over a period of time, one of them decays. That last one, it might not. When we talk about half-life, we use the notation T 1/2. And it's an estimation, but it works if we have a large number of atoms, which we pretty much always do. Mathematically, we would use this equation to describe it. N equals N naught e to the negative lambda t. Clearly, I'm going to need to define some variables here. N and N naught are the amount, the original amount and the later amount. Because this is something that's on both sides of the equation, it can be in any units we want as long as we're consistent on both sides of the equation. So for example, it can be grams, it can be the number of atoms, it can be percentage, it can also become something we call the activity or the decay rate, which we will talk a little bit more about later. E is the natural E. Lambda is the decay constant. And T is the elapsed time. The decay constant is related to the half-life, and is related to the half-life by this equation. T 1/2 equals ln 2 over lambda. We will be using both of these equations in subsequent problems. We're going to need to talk a little bit more about units and things like that. Generally speaking, your half-life can be in any units for this type of problem as long as T and T 1/2 are in the same units. Meaning, one of them can, if half-life is in years, elapsed time is in years. If half-life is in seconds, elapsed time is in seconds. Another form of this equation you might see on some occasions is this can be arranged to be N over N naught equals e to the negative lambda t, where N over N naught is the fraction remaining. So if we have 75% of something remaining, we would put in a 0.75, for example. Okay, we're going to take a look at some sample problems now.